So Manuel worked all summer and saved $1,092. Now he plans to spend $35 a week. Does this table look familiar? To what? The one we did before, right? The only difference was that table was about Susan, right? Susan, okay? So what's Manuel's table going to look like? After 0 weeks, $1,092. So what was the process? $1,092. Okay? What's next? 1 week, okay? So after 1 week, oh, see, that is a little different than Susan's, right? Because we have to subtract 35. What is 1092 minus 35? 1057? Is that what you said? Good, that's correct. What about after 2 weeks? 1092 minus 35 minus 35, right? So 1022. After 3 weeks, 1092 minus 35 minus 35 minus 35. Ugh, that is so much to write. 987. Okay, my hand is tired of writing 35s. I wish there was a way we could shorten it up a little bit. Oh wait, there is? You're saying there is? Oh, good. So in the 4th week, how many 35s are we going to have? How do you know that? We haven't written anything down. How do you know it's 4? Right? Because after 3 weeks, how many 35s did we have? And after 2 weeks, how many 35s did we have? And 1 week? Even 0 weeks? 0 35s, right? So after 4 weeks, shouldn't I be able to say 1092 minus 4 35s? Oh my gosh, that's so much nicer to write. What is it? 952? So after 5 weeks, my gosh, my hand is feeling so much better now. 1092 minus 5 35s. 917? Good. Oh my gosh! Now it wants a function rule. Look how easy it is to write my function rule. What's my function rule? 1092 minus t 35s? Okay, well I just heard somebody say something completely different. They just said 1092 minus 35t. Oh, that's not completely different? Oh, okay, good. Is it the same? Are we good? Okay, so tell me why I wrote down the wrong answer then. Is this a function rule? Oh, f of t. Which means I also have to write f of t here if I happen to have both of these written, right? Good. Good. I'm glad you didn't let me trick you. Good job. Okay? Find a viewing window for the problem situation. So you remember on Friday we had that long conversation and half of you were asleep after it? Not really, I'm just teasing. Okay? We did have a long conversation about this though, right? Why did we have a long conversation? So that today we don't have to, right? So we would know what to do. Today we don't have to have a long conversation. What is my x min, my minimum x value, going to be for this problem? 0. What is my maximum x value going to be for this problem? 10 would be great. How are we going to count? By ones? What is my y minimum going to be for this problem? Ooh, that's a problem, isn't it? That one's not as easy to see this time. Which one is easy to see? The y max, right? What is the y max for this problem? Probably 1100, right? Or maybe even 1200 if we wanted to be really sure we could see everything that was going on. But a y min. How did we find the y max last problem? Do you remember? On Susan's problem? Yeah, we used what we used, or we put in what we had for the X max to see, to make sure we'd be able to see it. Guys, do you see it's the same thing this time? It's just the min instead of the max because we're decreasing. So what if we put 10 in for this? What's 10 times 35? 350? What's 192 minus 350? And I don't want anything exact. I want a nice, round, pretty number. Yeah, 600. Right? Does that make sense? Are you lying? Okay, good. It doesn't make sense? Okay. I put in 10 right here, right? That gave me 350. Let's say 1100 minus 350. What is 1100 minus 350? Do you know off the top of your head? Get your phone out. It's not a trick. I promise I'm not going to try to take it. Do 1100 minus 350. What? 750? So we could have used 750, right? But we wanted a nice round number, and 750 is good, but I wrote 600 because somebody said 600. Fair enough? We okay with that? Bailey, does that make more sense? Are you lying? No? Okay. How do we want to count? Hundreds. So on our graph, let's go ahead and draw this, right? Why aren't we using a graphing calculator for this? It's not time yet, right? We don't have them yet. Okay? So 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I kind of messed up on the end, sorry. Will you forgive me? Thank you. This, though, is 600, isn't it? And especially because it's not 0, we really, really want to make sure that we have that labeled, so if we come back later and look at it, we're not going to mess up because of it. 10, 8, 9, 10. Okay, do you have all yours labeled? So what does my graph actually look like? Where does it start? How much money did Manuel have to start with? 1092. So it's somewhere way up high up there, right? And this line is decreasing. Oh my gosh, what were you supposed to do today? Explore increasing and decreasing functions. Oh my gosh, we're doing it. It's going to look something like that, isn't it? Justify your window choices. We did in our conversation. I did. How much money will Manuel have after 11 weeks? Well, can we use this? Can we say f of 11 equals 1092 minus 11 times 35? Can I do that? What is 1092 minus 11 times 35? 707. Now guys, if all I wrote was 707, would that be the right answer? No. What did I put to help me get the right answer? Dollars, right? I put the dollar sign because it's asking me how much money. We have to answer the question that's being asked. Okay? When will Manuel be out of money? How would we figure that out? Sir, divide what? Good guess. Good guess. Yes, ma'am? How could we do it mathematically? Wouldn't the value of the function be 0? Or t, I guess I could have used t because we've used t the other times. So what happens if I add 35x to both sides? I get 35x equals 1092. To solve for x, divide by 35, right? That's not what you said, is it? I know that's what you said. Is that what you said? Okay, okay. Just making sure. So x equals what? Bailey, you still got your phone out? Would you do this for us, please? Because we have to have a conversation. Because 1092 divided by 35 is what? 31.2. Yes, ma'am. Okay, that was funny. When will Manuel be out of money? According to this answer, my answer should be what? 31.2 weeks. But how many times a week is Manuel spending $35? Only once, right? It's only coming out one time. So can we have 31.2 weeks? No. So is it 31 or is it 32? Bailey, you got your phone out still? Okay, you ready? 1092 minus 35 times 32. So if it's 32 weeks, at 32 weeks, Manuel has negative $28. Ready, Bailey? 1092 minus 35 times 31. So after 32 weeks, he has negative $28, and after 31 weeks, he has $7. So how do we answer this question? Once he gets to 31 weeks, can he spend $35 more? No, he cannot, can he? Okay, so
Kingston,
yes, ma'am.
do you have Chesney Gray?
Yes, ma'am.
She needs to come to the office. She is sleeping.
Thank you. Chasney, you need to go to the office. You're leaving. Okay. So let me ask this again. When he gets to 31 weeks, can he spend $35 more? So technically, is Manuel out of money? No, because he still has $7. But can he go another week? So how are we going to answer this question? 31 weeks. Very good. I'm finishing this video. Obviously, I'm making the video right now, so it'll be on my blog. So just you can go watch the end of it to get the rest. Okay? See you later. Any questions about this? Now, guys, does this page look familiar to you? It should, right? How similar is it to Susan's second page? It's like the same, isn't it? Just with all Manuel's information. So what is the coordinates of the point where the line intersects the y-axis? Here. What's the coordinates of that point? 0, 1092. Sorry. What does it represent for Manuel? At 0 weeks, Manuel has 1092. Yeah, $1,092, right? Okay. How will the line change if Manuel had initially earned $1,300? Because right now I know the line looks something like this, right? How's it going to change if he started out with $1,300? The y-intercept's going to be up, right? If I try to keep the same scale, it'll look something like that, right? So what changed? What stayed the same? The slope. What does the new function look like? In terms of f of x, f of x equals 1300 minus 35x. Very good. Any questions about that? Okay, so original line looks something like this. How will the line change if Manuel spent $200 of his $1,092 on school clothes? So he started with only $892. It would start lower down. Okay, I'll go with that. And look like that. What changed? Y-intercept. What did not change? The slope. And what's the new equation? Very good. Minus 35x. f of x equals 892 minus 35x. Ma'am. What about the 200? That's a good question. He had 1092 to start with, right? He started with 1092 and he spent 200. So when this whole time started, how much money did he have? 892. Does that make sense? Okay. How will the line change if Manuel starts with 1092 but decides he will only spend $25 a week? So my original line looks something like this. It would be steeper. Would be less steep, so starting in the same place, but like that. So what changed? What did not change? So what's a new function? F of x equals 1092 minus 25x. Does that make sense? What changes in the situation resulted in a change in the steepness of the line? How much he spends? Sean, can you say it a different way? No? Same thing, right? I would only add one part to it. How much he spends per week. That's what I would change. Okay, we want that per in there. Does this result in parallel lines? This one changed in slope. Did it result in parallel lines? No. Not just no, but no! Right? Okay. What changes in the situation resulted in a change in the starting point? How much he started with. Very good. Did this result in parallel lines? We good? So this is where it changes a little bit. Because we talked about Susan, we answered all those same questions. We talked about Manuel, answered all those same questions. 13. Manuel has 1092 and he spends 35 a week. Susan has 34 and will spend 250 a week. Find a viewing window that includes both situations. What kind of viewing window do you think we're going to need to see both situations on the graph? What do you think our x min should be? Our minimum x value? 0 is probably really good. Maybe. What about our y max? You want to go with 10? How are we going to count? By ones? Okay, so what about our y minimum? If we want to see both graphs, probably 0. Maybe. What about our y max? 1100. And how do we want to count? Hundreds? So this is the graph you just drew with that window. You can kind of see Manuel's graph. Can you even see Susan's graph down here? So is there a better window? What should it be? What do you think we need to change to be able to see a little bit more? I am going already as high as I can to just barely see Manuel's. So that's probably okay. Maybe the x's? We don't really need to worry about negatives, do we? What do we want to change our x's to? Not 10, maybe 20, okay? That's what 20 looks like. Is that better? Ish, right? It's a little bit better. Can we get it possibly better? Okay, what do you want to try? 40? Ooh, that's good, isn't it? So let's change what we wrote down to be 40. I'm going to keep recording this so that it'll be on my blog if you need it. Did I give you the second page? There's a page at the front of the room called Rate, Recursion, and Relation. You need to pick one of those up before you leave, and it is homework. But I will do most of this on the video as well. Okay? So we need to copy the graph from the calculator. Excuse me. Onto from 0 to 40, from 0 to 1100. This is going to look like this. This is going to look like this. Okay? Justify your window choices. We chose these window choices because it's what we needed. What we needed to have a good picture of the situation. Okay? So, when will Manuel and Susan have the same amount of money? Manuel and Susan will have the same amount of money when you can take their two equations, so 1092 minus 35x, and set it equal to Susan's equation, which is 34 plus 2.5x. Okay? When those two equations are equal, then we'll know when they have the same amount of money. Okay? So if let's add 35x to both sides, and let's subtract 34 from both sides. When I subtract 34 from both sides, I get 1058, and that's 0. When I add 35x to both sides, that's a 0, and that is 37.5x. All that's left to do is divide both sides by 37.5 to get that x equals 28.2. Okay? Now, we know that that can't be real because we can't have the 0.2 of the week. So really the answer would be what? Well, are we going to have really one? When will they have the same amount of money? They won't ever have exactly the same amount of money, but it'll be closest at 28 weeks. So we're going to put 28 weeks. Okay? How much money will Susan have when Manuel is out of money? Well, if you remember on the front, we calculated when Manuel will be out of money, and it'll take 31 weeks. So if we take Susan's information, which is 34 plus 2.5x, but I put in a 31, that will tell me 31 times 2.5, whoops, not times, 31 plus 2.5 times 31. Sorry, 34 plus 2.5 times 31. And that'll give us an answer of 111.5. How much money will Susan have? So we know it's $111.50. So Susan will have $111.50 when Manuel is out of money. Okay? The other page that I'm asking you to do today is Rate, Recursion, and Relation. All right, that's just looking at these three graphs and focusing in on some questions that are being asked. Which student started with the most money? Well, a starting point is that y-intercept, so which one of these y-intercepts is the highest? Okay, hopefully you see that Yen's is the highest. Yen started with $20. Okay, because his y-intercept is the highest. Okay, which student started with the least money? Well, again, looking at the y-intercept, hopefully you see that Lyra started with $0. Okay, her y-intercept is the lowest. Which student is saving the fastest? Well, hopefully you'll see that Lyra's line is the steepest, so she is saving the fastest. Just to be sure, after 2 months, Lyra has $60. So my slope would be my rise over my run. So 60 divided by 2, she's actually saving $30 per month. Okay. Mark, on the other hand, after $30 after 2 months, so he's saving $15 a month. And 20, no, we can't even do that. 40, after 1 month, it's 40. Is that what I want to say? Oh no, because he started at 20. Okay, so after, let's see, that's a difference of $40 after 2 months, so he's saving $20 per month, which makes this wrong too, because he's 20 after 1 month, 30 after 2 months, so that's only actually a 10. Okay, so Lyra is saving the fastest because she's saving $30 per month, and her line is the steepest. Okay, so at the same time we figured out D, which student is saving the slowest. We know that that's Mark, so his is the least steep, and he's only saving $10 per month. Okay, number 2, all these same kind of questions about these three graphs. Which student started with the most money? Again, it's the y-intercept that's the highest, so this is Frank. He started with $80. Which student started with the least money? The lowest y-intercept, so that would be Rubel, because he started with $40. Okay, which student is spending the fastest? Again, we're looking for the steepest line. Okay, which one is the steepest line? Well, sometimes it's maybe not exactly hard to tell, or excuse me, as easy to tell. So sometimes you might want to actually figure out what the slope is to know who is steeper or less steep. But in this case, hopefully you can see that it's peso, because after 2 months he has spent $60, so he's spending $30 per month. Okay, who's spending the slowest? This is the least steep line, and the least steep line in this case is Rubel. Okay, because after 4 months he has spent $40, so he's spending $10 a month. Okay, on the back, 3, 4, 5, and 6. These are those recursive functions we were working on earlier in this unit. So we're starting at 1,000, or we're starting at 35, or we're starting at 1,000, or we're starting at 35. So hopefully you realize this one is starting at 1,000 and this one is starting at 35, the graph part of it. So if it's starting at 1,000, it's either minus 20 or plus 20. And hopefully you see that the increasing line is going to be the plus 20. So this one is going to be A, and this one is going to be B, number 3. Okay. Now when it comes to these two, when it's starting at 35, it's either plus 3 or minus 3. Even though it's a really small change, still the positives are going to be the increasing. So here's C, and number 6 is D. Okay? Notice I left some room because I also have these, the functions. Okay? This says I started with 35 and decreased by 3 every time. Okay? So if I start with 35 and decrease by 3 every time, this one is I. Okay? Starting at 1,000 and decreasing by 20 every time would be this one, starting at 1,000 and decreasing by 20 every time. So this one is B and II. Okay? The third one says starting at 35 and increasing by 3 every time. Starting at 35 and increasing by 3 every time. So this would be III. And then, hopefully, we only have one left, but we need to make sure that that's right. We start with 1,000 and increasing every 20 every time, and that is correct. So that is IV. Okay? So I'm going to leave 7, 8, and 9 for you to answer for yourself. Okay? I hope you have a great day. Peace.